Okay, good morning, everyone. My name is Carlos Salazar. I am a PhD student in the Department of Mechanical Engineering, and I'm part of the Smart Tools project. Today, we are going to introduce low-cost welding monitoring techniques, a simulation versus a real welding environment. So, some challenges behind welding is that it relies a lot on a practical experience and on hands-on training. So it requires some physical equipment and consumables that may be really expensive. Additionally, novice welders need to practice a lot, and they have limitations on training facilities and experienced instructors. That is really important because when you are learning, you need some feedback during the learning process. Additionally, welding could be intimidating for some people because it is really noisy, it has high temperatures, sparks, sound, high voltages, and high currents. So to address those kind of problems, we developed two solutions. The first one is a simulation. We call it a simulated welding environment. This environment was developed in a software called Unity. We designed digital elements of the physical elements in a welding environment. In that simulation, we added some coding for the interaction between those elements. And an advantage of Unity is that we can export it on an APK format, which means that we can install it on Android or iOS phones. So it will be really easy to have it on your hands, basically. From the point of view of someone that is using the simulator, is basically that screen on the picture number 5. In addition to that, they need some setup. They need VR headsets, they need a weld torch, and the place that you are going to weld. During that process, we collect data, and we measure some welding parameters that are really important. We collect that data, and we save it in a CSV file. And we can post-process that information, or we can analyze it once we finish that process to give feedback and maybe to improve the technique. But what users need to know is that we're going to provide an app. They are going to install it on the phone. In addition to that, we're going to provide some physical elements, and they can begin playing or practicing at home, during breaks, or whenever they have time, just to improve the technique. So what we need is the phone. We need a VR headset, which is this one. We put the phone here. Obviously, we open the simulator. We need this element that is the joint that we are going to weld. We need a torch. And you just need to wear it, and you can begin playing and practicing. From the point of view of someone that is using the simulator, he's going to watch something like this. We provide feedback in two different ways. The first one is at the top, which is the welding parameters. It is the stick out, or the distance between the tip of the torch and the place that we are welding. We provide feedback of the angles that the person is using. It is working angle and travel angle. We also provide the speed. Those parameters are important in this kind of process. So the big screen shows the point of view of the user, and at the bottom we have the point of view of someone that is not using the simulator. It is basically augmented reality. And it uses, I forgot to mention that we also provide feedback in a different way. In the torch, we have a circle that provides feedback of the angles that you are using, and a bar at the tip of the torch that provide feedback. That means the distance between the tip of the torch and the surface of the plate. If you install the app, you just need to face the camera to the markers, and the simulator is going to render the elements in the simulated environment that you can begin practicing. We are planning to test this simulator with 20 ACC students, Austin Community College students. And to do that, we previously made a pilot test with 5 students just to have some feedback, like things that we need to improve, the interaction between the simulator and the user. But after this pilot test, we are going to give this setup to 20 students. They are going to have about 1 to 2 months to test it, and we need to probably provide or test if it accelerates the learning process for novice welders. Now, this is just a simulator, or the previous explanation was just a simulator as a complementary educational process in the learning process. Now, in a real welding environment, we need to give some feedback as well to the user. So to do that, we developed this welding sensor unit. Inside this welding sensor unit, we have low-cost sensors. It has 1 IMU to measure the angles, 3 distance sensors to measure the displacement, velocity, and the distance between the tip of the torch and the surface. We have a servo motor, we have a sound detector because sound is really important in a welding process. And it'll be really easy to clamp it to a real weld torch. Basically what we need is the same that we use in a real welding scenario. We need the gloves, we need the helmet, we need the plates. We need a torch with the device that we developed. In addition to that, we need some reference. So in the left part, we have a reference to measure, it is going to help the sensor, the distance sensors to measure the displacement and the speed. And you just need to attach it to your weld torch. You need to press the set button, and it is going to set the 0 and begin collecting data. And you just begin welding, basically. We use it just with an Arduino board and the laptop to collect information. But in the future, or the future steps of this project, is to use a machine learning model to predict the quality of the weld bead, or probably predict the shape of the bead, based on the data that we are collecting. So basically, we have some angles and distances, and we are going to predict the shape of the bead itself, and it is going to affect directly or indirectly the quality of the bead. In addition to that, now that we are measuring all these parameters, we can provide in a kind of feedback, or probably in the helmet, feedback to the user, because when you use the mask, you cannot watch the surrounded areas. You can just see the dot, which is melting the metal. So the goal is also to provide some feedback. Probably in the helmet, we are going to provide a kind of similar screen to the simulator, like saying the angles that you are using, if you need or you don't need to fix those angles, or probably some haptics. It means a vibration on your hands. Let's say that you are tilting to match the torch, so it's going to vibrate here, and you're going to fix that angle. The same with the speed. The goal behind that is to accelerate the learning process and to help welders to develop those skills. The simulator is going to be a complementary tool that you can practice at home, and it's going to be really cheap. And this kind of device is going to help in a real welding environment. Thank you. Do you have any questions?
Thank you so much. This is so exciting. As somebody who welds not well at all, I would absolutely love to be able to practice before the sparks come flying. So I'm really curious, with the people that you've worked with so far, your 5 testers, were they all inexperienced welders, or did you also get some people who have a little bit more experience to give you input into the process that you're developing?
3 of them were novice welders. They just started the program at ACC, and 2 of them had some experience. And they gave us really important feedback because they have the experience, they have the knowledge, so they gave us some advice about what can be improved in the simulator, and they said something that it is really good in the learning process. For example, the feedback is really important, especially for novice welders. They had experience and they had a good technique. We have some videos, but we cannot share those videos. But we can notice that novice welders had a bad technique. On the other hand, experienced welders began like this, welding. They didn't need the feedback, in fact. They had the experience. But I'm going to emphasize this. Since it is low cost, they were really excited to try it at home. They don't need to buy the equipment. They don't need to expend money on consumables. So they were really interested in this project.
Carlos, really nice job. The project's come a long way. It's really nice to see this. Troy, with ACC, I wonder if you could share a bit more about your perspective and how you see this kind of integrating with ACC and just your experience with the project.
Thank you. So I've been a weld trainer for about 18 years or so. I've been a full-time faculty member at ACC for 17 years and department chair. And so I'm naturally very skeptical of this, because I'm not quite sure how it works in training. But after playing with it a little bit and seeing what Carlos has developed, I think it can help as a supplement to training. It can enhance a student's training and probably speed up the learning curve for welding. One of the barriers that we see is that you can't weld in your apartment. Welding equipment is expensive. There's the obvious fire danger of welding in your apartment living room. So this gives students an opportunity, and there are welding simulators out there. You can buy a welding simulator, but they're expensive. But if you can give this to a student for $20 or around there, and they can take it home and practice these things, where if all things are equal, if they abide by these welding parameters, usually will produce a sound weld. And so I applaud it as a supplement to weld training. They still need to put on the heavy welding gear. They still need to feel the sparks coming down on their neck and not flinch. All those things still have to happen to be a good welder, I think. But this should help speed up the welding curve, I think, the learning curve. Thank you.
So I'll be a student with the ACC welding program this summer. Yes. And I was curious because I know there's different speeds for different metals and temperatures. And so I was wondering if there was a way to adapt for that, or if there's different programs that you can use on that would apply for different metals.
No, for now the simulator is just for one joint. It is a corner joint for MIG process. But in the future, depending on the feedback that we get, we can scale this. This simulator works with different positions, like flat position, overhead, and so on. But it is limited just to one joint. But in the future, we can develop for different joints. On the other hand, the welding sensor unit, the device that you attach to the weld torch in a real welding environment, it can be used in different positions and with different metals, with different thickness and different joints.
A little bit, please, about the collaboration building up to this point.
Between the Austin Community College?
Well, whatever it sort of took, give us a little perspective, time-wise, institution-wise, individual-wise, to come to this to come to your product?
Sure.
Yeah, thanks. We were approached by UT a couple years ago now, and Sherry and Tina and Chelsea, they wanted to study how we taught welding, and they wanted to, so they spent, and Carlos, a lot of time in our welding labs at both the ACC Riverside and Round Rock campuses, where we have students that are from 16 years old to 60 years old. It runs the gamut, and they spent a lot of time observing the instructors. They saw how welds were made, and it was exciting for us too, because we question, are we training the best way? We think we produce great welders, and we think we do them in a pretty a quick manner, right? We can pump them out and they win welding contests, but there's always a better way to do things usually, and so we're interested in that, and we want to be a part of welding education, and so we were very thankful and happy to join with UT and be a part of this research. So we appreciated it. Thank you for inviting us.
In addition to that, Chelsea and Tina were talking with ACC students about welding in general. I took the feedback from the welders as the input of my project. For that reason, I developed a welding simulator. They mentioned that it is really difficult to practice at home because they don't have the equipment. They have to buy materials. They cannot practice like every single day or every single week because they live far from the facilities of Austin Community College. So we try to solve those problems. So the input was, and it is important to collaborate between departments. They are part of the social science team. I am an engineer, so we engineers always try to just solve problems and don't think about people. So the feedback was really important, like what kind of features we need to develop to address the problems that ACC students were having.
I know that this is for training purposes, but I was curious between like the weight difference between the torches and if there's any value in upping the weight of the ones that you train with.
That is really important. That is really, really important because this is not heavy. This is really light. And when you jump to a real welding environment, there is a difference because the torch is heavy. Additionally, you have the cable and different conditions like the heat or the sound that it produces. So we were discussing that, and since we try to make it low cost, we're not using a real weld torch with the real weight, but it is important because during time, let's say that you are gonna weld for 5 hours in your job. So probably after 2 hours, your arm is gonna be tired. That is completely normal. Whereas our simulator, which the torch, you're not gonna get tired. And probably we need to fix that kind of things. But yeah, we are trying to get some more feedback to the users and trying to improve. But yeah, there is a difference.
Hi, Carrie Stevens from UT again. So I'm curious if you could expand a little bit more about how the machine learning is going to work. Is that on an individual basis to give people feedback so that they can improve their weld, like what kind of things will the machine learn about how people are working with the welding practice?
Okay, in a real welding environment, we can take two ways. The first one is just to give feedback. So since we are measuring all the parameters, all the angles, distances, it is going to be really easy to give feedback. Like in the simulator, we don't need a machine learning model in that case. Now, when we use that data, we can train a machine learning model just to predict the shape of the bead. So the input is going to be the current, voltage, angles, distances, and sound. And we are going to generate a 3D representation of the bead. And we can analyze the quality of the bead based on that, based on those parameters. Because, for example, if we are welding that joint, it is a corner joint, ideally your angle should be 45 degrees to melt both metals. But if it is more than 45, probably you are adding more metal to the horizontal plate and you are not melting the vertical plate and you have an undercut. So based on that input, we try to train a machine learning model based on the angles and speed, obviously, and predict the weld quality, basically. Like you have an undercut here, you have a crack, you have some porosity, based on those parameters. But yeah, we are going to use ML to do that. Thank you.